So what we're going to see first is how to graph a quadratic that's written in this form. So what is this form? This has a squared still, but it's not written as ax squared plus bx plus c. That's how we saw them before. Now it's written, so this is like, say, standard or general form. And then this is the completed square form. So that is like x plus a number squared plus another number, okay? So something like that. So you can be given it in either form. It's just two different ways to write it, but they mean the same thing. How can you switch from one form to the other? Like, how can we go from this completed square form to the one we know better? Foil it out, right? So we can do that. Like, if we wanted to write this in standard form, we would write that bracket out twice. This is squared. Foil it out. I'll just do that quick. But you know how to do that. And there it is. That is the same equation. If you were to graph them and find the vertex, it's the same graph, it's the same equation. They hold the same set of infinite points that if you drew them all would be a parabola. But they look different. So it's just two different ways to write the same thing. It's if you put on a different outfit the next day, you're still the same person, but you look a little different. Okay? Same equation, they have the same points, they mean the same thing, but they don't look at all related, do they? No. I guess you'd have to cut your hair too, maybe, to look very different. So if we were to, let's just split this page and say we have this one, and then the standard form over here. So the vertex, let's do the one we know first. How do we find the vertex? X equals minus b over 2a. So minus a minus 6 over 2 times 1. 3. Okay. Now what do we do with that? That isn't a point yet. It's just the x value of the vertex. What do we do to find the y value? Plug it in to the original equation, and so we need to find y. So we plug it in, 3 squared minus 6 times 3 plus 10. So 9 minus 18 plus 10 is 1. So here's our vertex. Not too hard to do that. You know your formula, you take that number, whatever you get, and you plug it in. Okay. Now over here, to find the vertex, do you see a 3 in that bracket? And do you see 1 over here? That's the vertex. So it's just given to you. It's easier to find the vertex. So the vertex is whatever makes this equal to 0. So x minus 3 equals 0 gives me x is 3. That's all you do for the x value instead of plugging it into a formula. And this is the y value, just whatever it is. So 3, 1. So if you have it in this form already, it's easier to get the vertex. But that's about it. You aren't going to, I'm going to show you how to go from standard form and write it in the completed square form, but in reality, you're not going to do that to find the vertex, because then that's more work. Because you have to switch it, and then you read off the vertex, where this one you could just plug it in right away. So you're never going to do that by choice, only if I tell you to in this class, complete the square. That would be in the question. In real life, sometimes we need to write things in a completed square in order to do something else with the equation, so that's why we're going to practice it now. Okay? It's not because it makes things really that much easier. But if it's already like this, then it's easy to find the vertex. Don't multiply it out and do this. Okay, so does that make sense? Now what else do we need if we were to graph this parabola? The x and y intercepts. Those are easier to find if you multiply it out and use this. There is a way to rearrange this, but I find people mess it up too often. Okay, so you would actually just have this. There's not going to be any, so in either form, let's write this down. To find the X-intercepts, write the equation in standard form, and then either factor or use a quadratic equation. So there's nothing different about it except that it's the same as before, what we were doing. So you would say, okay, well, I need the x-intercept. So I take my x squared minus 6x plus 10, set it equal to 0. Does that factor? Two numbers to multiply give 10. 2 and 5, that won't give us 6. 1 and 10 won't give us 6. So quadratic equation, minus b, plus or minus square root of b squared minus 4 times a times c. What happens? Negative. Okay, so let's talk about this. There's no x-intercepts. Why? There's a negative under the square root. 36 minus 40 is negative 4. No x-intercepts. No x-intercepts. Negative. Now, I want you to look back at the completed square form. How could we tell that there's no x-intercepts right now without doing anything? Any ideas? It's actually really easy. If this is plus a number here, that means the graph went up and it's above the x-axis and opens up, so there's none. So if you are given it in this form and there's a plus, like any number over here, you already know that there's no x-intercepts. Now if that said minus, then there would be. Okay, so it's just a little tip. You may not ever use that tip, but if you know that this goes up, and that's what we're going to do later, is we're going to take this in just a minute. I'm going to show you that you move this to the right to plus 3, up 1, that's the vertex, and then it opens that way. So you already have the graph, but you still need the x and y-intercept if they have them. So what about the y-intercept? Let's squish it in, because it's easy. That's the one where you let x equal 0. So 0 squared minus 6 times 0 plus 10 is 10. So 0, 10. Now if you plugged it in here, what would you get? If you plug 0 in, what do we get? Minus 3, yeah, squared. What's minus 3 squared? 9. 9 plus 1? 10. Right, so you can just plug it in here. We're going to do a bunch of these. Okay, so let's just graph it. So we have a vertex 3, 1, and a y-intercept 0, 10, and no x-intercepts. One, 2, 3, up 1. And this has to cross at 10. My scale's off, but there it is. I didn't put it down low enough. You can do better. But there it is. So realistically, if you get this equation, this is how it works. Anything in the bracket, this moves left or right. How do we know which way? Well, whatever makes it 0 is 3, so it moves over to the right, because 3 is on the right, by 3. So it moves to the right 3. And this plus 1, that's the y value, so that moves either up or down. Down if it's negative, up if it's positive. So this one moves, plus 1 is up 1. So what does that even mean? What's moving? Well, it is just the regular parabola. So here's x squared. If you go to the right, so it's like you're picking this up like it's a piece of plastic bent to look like a parabola, and you pick it up and move it. Instead of being at 0, 0, you're moving that point to here, and then you're placing that piece of plastic that looks like a parabola back down. That's what you're doing. You're like picking up the graph and moving it. And this is like 100% correct for anything you need to do in calculus. You just need to know where the graph goes. Sometimes you need to know the intercepts, and then at that point you'd say, well, this has no X-intercepts, so I don't even need to find them. But it is going to go through the Y-intercept, so I would then plug in 0 and see where it goes through. And that's at 10. But this is doing it by what we call transformations. Do not get caught up in if this is a minus, move to the right, and if this is a positive, move to the left, because it depends, like if x is negative or positive. That doesn't always work, is what I'm saying. But in general, or often, it is. But it's really, it moves to the number that makes whatever's inside that 0, inside that bracket. Okay, so don't get caught up in if that's a minus, I move to the right, and if it's a positive in the bracket, I move to the left. Don't do that. So I said it moves to the left or right by this, setting it equal to 0 and solving. That's how you know which direction. Okay, because I can make them that don't move that way. Okay, example 2. So what we're going to do is draw the parabola using transformations. I'm just going to do that. I'm not finding the x and y intercepts for now, but we'll look and we'll find them in a minute. Okay, so we'll add a little bit to it. So if we want to draw this using transformations and it's given in this form, it's really easy to do. So here you say what makes that 0 is -2. So that moves towards the -2. So that's the left 2, if you want left or right. And this, because it's negative, it moves down 3. So what's moving? What is moving? Remember, it's like you have a plastic parabola that you pick up and move it around. But what is moving? What part of the parabola? The vertex. It's like that point 0, 0 moves to this new point. The new point is -2, -3. That's the vertex. -2, -3. So -2 and down 3. Now I'm going to draw this small. Why? I'm not sure where it goes through the X and Y axis, and I could draw it very wrong at this point, because I could do this. And that has the right vertex, but it might not be the right parabola. And the only way to know exactly where it goes is if I really had a perfect parabola in plastic that I moved and we could look at where it goes, or I actually find the X, Y intercepts. This is wrong, I think. Most likely it's not. Where else could it be with that vertex? It could go through like here, or if it was wider, it could go through over here. Right? And if you draw it without actually finding the intercepts, you might have drawn the wrong one, even though the vertex was right. And that's why it's important to know how to do that. So how do we find the intercepts? So for the x-intercept to let y equal 0, is there going to be x-intercepts first? Yeah. So we're going to find them. If you knew by transformations, by just moving it around, that there wasn't going to be any, you skip that step and you say there's none. Because this is the harder one to do. How do we do it? We take our equation and we FOIL out the bracket. X squared plus 4x plus 1. And then either factor or use a quadratic equation. Which is this one going to be? Yeah. Does this factor two numbers that multiply to give 1? It's not going to give us 4, is it? Quadratic equation. So you don't want to go through this if you already know it has none. Right? So it's good to draw like a quick sketch using transformations first, and then you say, oh, it's definitely going to go through the x, so I need to find them. So this should work. So minus b plus or minus square root of b squared for 2a. So minus 4 plus or minus 16 minus 4. So 12 is, you can break down to be 4 times 3. Square root of 4 is 2. Root 3 doesn't have a square. There. And then what's our answer to this? Remember the 2 goes with both pieces. So this would be minus 4 over 2 plus or minus 2 root 3 over 2. Minus 2 plus or minus root 3. Okay, how do we write that as a intercept? One of them is minus 2 plus root 3, comma 0, y is 0. The other is minus 2 minus root 3, comma 0. So we need to know where those are on that graph. So we have to do our estimating if you have no calculator. At home, take out a calculator. Right? Someone asked me that, but of course you can do it. But on a test, you won't be able to. So it would be good to, at home, if you were doing this, guess, and then do it on the calculator and see if your guess was good. Right? So we need to guess what these are. Root 3 is what? What do we know that's close? We know root 4 is 2, and root 1 is 1. So it's between 1 and 2. Which one's it closer to? 1 or 2? 2. So let's say 1.7 as my guess. So the first number is 2 plus 1.7, which would be negative 0.3. So the first one is around negative 0.30. And the second one, minus 2 minus 1.7, is around negative 3.7. So just looking up here, which one was my closest guess? 1, 2, or 3? These are both negative numbers. Well, 2 went through 0. I would say this would be closer because I didn't really say a scale, and they're both in the negative, right? I would say this one would have been my best guess. It's probably actually not what I would have guessed if I was just drawing it. I might have drawn it out. I'm not sure. So, but let's draw it for real. We need the Y-intercept, but remember that one's easy. So we've already multiplied it out, so we could use that form. So 0 squared plus 4 times 0 plus 1 is 1. 0, 1. Okay, so we're going to write our points the right way, not our guess, but we're going to use our guess to actually plot them. So we have a vertex -2, -3, a X-intercept, and a Y-intercept 0, 1. And these were, say, around -0.3 and -3.7 for these two. That's just off to the side so you know where to graph it. So vertex always first. So 1, 2, 3, here and here. Is this one, before we start, this next one, does it have X-intercepts? Yeah. And how do we know that? Right, because it's going to go down 5. So by transformations, just by our quick guess, we would say the vertex is what makes that 0, which would be 3 and -5. So 1, 2, 3, and down 5. So is it going to go through the x-axis? Yeah, so we need to find both sets of intercepts. Now, the Y-intercept is the easy one. Let me show you doing this one first. If we don't FOIL this out and we just plug it in, what do we get? -3 squared is 9. 4. So it goes through up here. And then you could almost guess where it goes through. A little bit more accurate. If you knew that Y-intercept, you can kind of draw it. You know for sure the point's not going to be over here because then you can't connect to that. Okay, so the X-intercept. You have to FOIL that out, and then remember to subtract the 5, because there's a -5. set that equal to 0, and quadratic equation. Minus b squared minus 4 times a times c Is there ever a time we don't have to use the quadratic equation here? 36 minus 16, 20. 20 is 4 times 5. And same thing, you would take your guess. Do we want to write out the guess? What's that close to? It's close to 4, but a little bigger or a little smaller? A little bigger. Root 5, like root 4 is 2, and then the next one up is root 9 is 3. So we could say this is like 2.1 or something. 2.2, whatever you want. You just need it between the right two numbers. So if we had 3 plus 2.1, that would be 5.1, and 3 minus 2.1 is 0.9. So I'm a little off at my guess, if you look back, if I go by my tick marks, because this would be 1, so I made it a little bigger than 1 instead of a little smaller. Right, but I was pretty close. So 3 minus 5, always your vertex first. 0, 4. And then we had 0.9, so here, and 5.1 here. But don't write 5.1 and 3.9, write the actual, this was the plus, so 3 plus root 5. And this one is 3 minus root 5. Any questions? Now, they can be completed squares with zeros in them too, so they can look like this. What's 0 here? Whatever was added or subtracted at the end. So what would be the vertex here? So this, it would be -1, and that's missing. So what would it be? 0. So -1, 0. Now let's draw a rough sketch to see what we need to do next, to see if you need the X or Y intercepts, what you need. So this is using our transformations. So -1, 0 is here. What do you think? That is the vertex, but it's also the X-intercept because it's on. So this is both the vertex and the X-intercept because it's on the X-axis. And there's no other points on the X-axis. So we just need to find the Y-intercept, where we let X equal 0. And then we can draw it for real. So -1, 0, and 0, 1. And just quick. Now, how do we know if they're in the completed square form, if they're upside down? How do we know that? Where does the negative appear? There can be negatives in lots of places in this, but there's only one place that actually makes it flip upside down. and has to be in front of that bracket that's squared.
To become positive.
So it doesn't become positive. Yeah. So the negative has to be in front of that bracket, has to be in front of the bracket, and that's a flip. So when you're doing your transformations for this, you know that it's going to look like that instead. So if you're using transformations, then you do need to remember that that in front of the bracket flips it upside down. What would the vertex be here? So what makes this 0? 5. And there's nothing added here. So 0. 5, 0 is over here. And it opens down because of that. Do we need to find X-intercept? No, we already have it. Y-intercept? What would that be? Squeeze it in here. Yeah, is it 25 or negative 25? There's a negative in front, so that stays there. This would be negative 5 squared, which is 25. It doesn't make sense that it would be positive 25 anyway, right, if it's opening down. So it is good to know that with that minus that it would be down here. Now, I would probably go by 5s or something if I was going to draw that. Let's draw it on the next page. So you might go 5, 10, 15, 20, 25. Okay, so this is a minus in front, so you know it's upside down. So that from this minus, we know that the graph is going to go that way. What does that 3 do? Same as what I said before when they were written the other way. It makes it skinnier. But does it matter? No, because you're going to plot your points, and it will just naturally be skinnier because you plotted the right points. So that a number in front of the bracket like that does not matter. Okay, because it's going to take care of itself. But the minus in front, if you're using transformations to get a rough idea where it is, that's important to know. What's the vertex? Negative 1 and 2. So negative 1 and up 2, whoops, is here. It's upside down. So it's going to cross all these places, so we need to find all the intercepts. So let me show you how to expand this, because you have to be really careful when you expand it to find your let's do the Y-intercept first, because that one's easy. So minus 3, that's 1 squared is 1. So 0 minus 1. So it's going to be down here. Okay. So we need to expand that all to find the X-intercept. So let's write it out carefully. So that bracket we need twice. We need to FOIL it out, but what happens with that minus 3 after? It has to multiply by everything through here. So you would leave that out front, and I would just put a bracket around. FOIL that out. So this would be x squared plus x plus x plus 1 and then the 3 has to go through. There it is. Now, if we're setting this equal to 0, I don't like all those minuses. And what do we always do if that first term is minus when we're going to factor quadratic equations? Move them all to the other side so they're positive, or change all the signs so they're positive. So this would be 3x squared plus 6x plus 1. And the answers to this and the answers to this are the same, so it doesn't matter which way. So let's use the quadratic equation. Minus b squared all right, 36 minus 12. 24. Does 24 have something that we can do the square root of? 4? 4 times 6? 6, we don't know the square root, so 4 times 6, 2 root 6. This has fractions in it. The 6 will cancel, but that 2 won't. So we'll have minus 6 over 6 plus or minus 2 root 6 over 6. So my 6 over 6 is 1. This 2 cancels and would give me plus or minus root 6 over 3. So this is kind of crummy to figure out where it goes, but it is what it is. Root 6 is close to what? So yeah, root 4 is 2, root 9 is 3, so it's between these. Halfway, less than halfway, what do you think? Maybe 2.4? Right, it's 2 away from there, but it's 3 away from here, so a little closer to the 4. But now it's divided by 3. What do you think? So you have to think about that, and let me give you a tip. Does 2.4 divide by 3? And how do we know that quick? Forget about the decimal. Does 24 divide by 3? Yeah, so 2.4 divides by 3. So it actually works out even. Now, if I had guessed 2.5, and now I said, oh, no, I have to divide that by 3. Does 2.5 divide by 3? No. Because 25 doesn't divide by 3. Pick something that works. Right? If you have to divide it by 2, don't guess 2.5. Just change the decimal, because it's just a guess. You really just need it in between 2 and 3 for it to work. So change the decimal. If you had guessed that this is 2.3, and 2.3 does not divide by 3, I'd say, yeah, I'm going to go close, but not that. I'm going to go 2.4. What's 24 divided by 3? 8. So what do you think that is? 0.8. So this is minus 1 plus or close to 0.8. So minus 1 plus 0.8 is minus 0.2, and minus 1 minus 0.8 is minus 1.1, which we only need to draw the graph. So our vertex was minus 1, 2. Our X-intercepts are minus 1 plus root 6 over 3 and minus 1 minus root 6 over 3. And our y-intercept, 0, negative 1. Okay, so 1 we said is negative 0.2, and then they shouldn't look like straight lines. They should be bended a little bit. But this is a skinny one. It's kind of hard to draw. That looks too much like a V to me. But well, if they look very, very straight, then you kind of have to. But I would, if this were me, I would probably redraw it a little bit more bendy looking. Sometimes I do this, if I can't get it to look right, draw the graph about how skinny I want and put everything around it. Do you know what I mean? It's hard when it gets squished. Okay, so this, what we have to do next class is what? I give them to you like this, and I say complete the square. So you're going to, I'm going to show you how to transform it from this standard form into a completed square form. That's what we do next class, after the test.